Tech quest of the day. In this circuit shown, let us find the Thevenin's voltage. Before that, we have to know what is Thevenin's theorem. Thevenin's theorem states that any linear circuit, no matter how complex, can be simplified to an equivalent circuit consisting of a single voltage source with a series resistance connected to the load. Here we are going to calculate Thevenin's voltage. Thevenin's voltage is nothing but the open circuit voltage across the load terminal. Let us see the options. Option A 2.4 volts, option B 2.8 volts, option C 3.6 volts, option D 4.5 volts. The correct answer is 3.6 volts. The Thevenin's voltage can be simply calculated by using a theorem called as source transition theorem. Here the given circuit is a Norton's equivalent circuit. We are going to find the Thevenin's voltage and hence we have to convert this Norton equivalent circuit into Thevenin's equivalent circuit. For this we have to consider this branch. In this branch the current flow's direction is indicated by an arrow mark. The head of this arrow mark is considered as positive and the tail of the arrow mark is considered to be negative because the current flows from higher potential to lower potential. Here we are using the formula Ohm's law V is equal to I into R. By replacing this current source into a voltage source, the Norton's equivalent circuit is converted into a Thevenin's equivalent circuit. Here we are using a formula V is equal to I into R. Here I is 1 ampere and R is 1 ohm and hence 1 into 1 becomes 1 volts and the resistance remains the same. Here we are going to replace this Norton circuit as this Thevenin circuit. After replacement, the circuit looks like this. Here the 1 volts voltage source and 2 volts voltage source are in series connection. Whenever two voltage sources are in series, they get added. Similarly, the resistance 1 ohm and 2 ohm are in series connection and hence these two resistance gets added. After the addition of these voltage sources and the resistor, the circuit becomes like this. This is in Thevenin circuit, but the remaining circuit are in Norton circuit. So, we are going to convert this Thevenin circuit into equivalent Norton circuit. After conversion, the circuit looks like this. Here, we are using a formula I is equal to V by R. The voltage source here is 3 volts and the resistance is 3 ohm. Substituting these two values in the formula V by R, we get 1 ampere current and the 1 ampere current is here. As we know, the resistance remains the same. We have to replace this circuit by this circuit and the resulting circuit looks like this. As we know already, whenever two voltage sources are in series, they get added. Similarly, these two current sources get added as 1 ampere plus 2 ampere becomes 3 ampere. Here 3 ohm resistance and 2 ohm resistance are in parallel. The parallel calculation can be performed by 3 into 2 divided by 3 plus 2. That is 3 into 2 gets 6 and 3 plus 2 gets 5. Hence the resistance value becomes 6 by 5 ohm. And now we got the circuit like this. This is in Norton circuit. But what we have to find is Thevenin's voltage. And finally we have to convert this Norton circuit into Thevenin circuit to find out the Thevenin's voltage. For the conversion of the Thevenin circuit, we have to convert this current source into equivalent voltage source. For that we have to use V is equal to I into R formula. Here the current source is 3 ampere and the resistance is 6 by 5. Multiplying these two values, we get 18 divided by 5, which is approximately equals to 3.6 volts. And the circuit looks like this. This is the final circuit where we are going to find out the Thevenin's voltage. In this final circuit, two terminals are open. So, no current flows through 6 by 5 ohm resistance and 4 ohm resistance. Hence, the total voltage is same as V in, that is 3.6 volts. And the correct answer is 3.6 volts. Thank you.